The ash tree removal operation relies on the advanced capabilities of an EFR model, 655 6+6 knuckleboom crane, chosen for its exceptional vertical reach, articulation, and precise load handling control. With a maximum vertical reach of 126 feet and a lifting capacity rated at 8,030 pounds, the crane provides the stability and maneuverability required to dismantle tall, structurally compromised trees in restricted urban or residential work zones. Its multi-section boom design allows the operator to position the hook and rigging hardware with millimetric accuracy, minimizing risk during cuts. Mounted on a Freightliner 114 SD chassis, the system incorporates a 12-foot custom bed engineered by DEL. This upfit includes integrated outriggers, reinforced mounting plates, and carefully routed hydraulic lines to maintain structural rigidity and optimal weight distribution during high-reach lifting. The combination of chassis strength, hydraulic stability, and crane geometry ensures safe operation even when handling heavy, awkward tree sections. The target tree, a severely deteriorated 80-foot green ash, shows extensive emerald ash borer damage, resulting in weakened fiber strength and unpredictable load behavior. Its twin trunks, measuring 61 centimeters and 64 centimeters DBH, necessitate a sectional removal strategy. Using coordinated chainsaw cuts and remote crane controls, the operator lifts each cut section vertically to avoid torsional loading and prevent trunk shear failures. Once separated, each piece is guided into a controlled descent, rotated clear of nearby structures, and set down safely on the ground. This operation demonstrates how the EFR 655's precision, lifting power, and articulated reach enable efficient, high-risk arboricultural removals that would be difficult or unsafe with conventional equipment. The Nisula N5 is a compact rubber-tired harvester built around the principles of maneuverability, fuel efficiency, and reliable performance in thinning and medium-duty forest operations. Its reinforced chassis and high ground clearance give it the durability to navigate uneven ground, while the exceptionally tight steering geometry, achieving a turning radius of roughly 5.25 meters, allows the machine to work confidently in dense stands where space is limited. At the core of the N5 is an AGCO Power 4.9 AWF diesel engine generating 127 kilowatts, paired with a broad torque curve that delivers 750 newton meters at just 1,500 revolutions per minute. This power, combined with a hydrostatic mechanical transmission and axle differential locks, creates a smooth, controlled driving feel, whether the operator is creeping through a thinning corridor or traveling at transport speeds reaching up to 40 kilometers per hour. The hydraulic system also plays a central role in its capability. With a Rexroth pump supplying between 220 and 280 liters per minute at pressures around 210 to 230 bars, the N5 maintains strong, consistent hydraulic flow even during demanding head functions. This ensures accurate gripping, fast feed rates, and clean delimbing cycles. When paired with the Nisula 500H harvesting head, an efficient, lightweight unit weighing roughly 640 kilograms, the machine becomes a highly capable thinning platform. The head handles clean delimbing up to 430 millimeters and single-cut felling up to 500 millimeters, supported by an arrangement of 5 primary delimbing knives and an additional auxiliary knife. Its wide maximum opening, extending up to 720 millimeters with the outer knives, enables confident handling of larger stems without sacrificing control. Together, the N5 and 500H form a balanced, operator-friendly harvesting system. It delivers a combination of agility, dependable hydraulic power, and cutting performance suited for thinning, energy wood production, and final cuts on small to mid-sized stems. For forestry contractors seeking a productive, cost-efficient, and terrain-capable solution, the N5 stands out as a modern, purpose-built machine optimized for demanding Nordic-style harvesting environments. The tongue-and-groove tree felling technique is a specialized, highly controlled cutting method designed to enhance directional accuracy during a fall, particularly in environments where precision is critical. Rather than relying solely on a traditional open-face notch, this method incorporates an engineered interlocking shape between the stump and the tree. The cutter forms a raised tongue on the stump and a matching groove on the base of the tree, creating a mechanical guide surface. This geometry locks the two pieces together during the early moments of the fall, preventing the trunk from twisting, shifting sideways, or slipping off the hinge prematurely. After the front notch is shaped, the back cut is made with great care, ensuring the hinge fibers remain uniform and strong enough to control the descent. As the tree begins to tip, the tongue naturally tracks into the groove, acting almost like a sliding rail. This controlled engagement helps maintain alignment, significantly reducing the risks of barber chairing, kickouts, or abrupt lateral movement that can occur with compromised or heavily leaning trees. Because of its stabilizing effect, operators often choose the tongue and groove technique in high-risk situations, such as felling trees with heavy lean, working on uneven ground or slopes, or handling premium saw logs where preventing twist damage is essential. By blending precise geometry with disciplined cutting technique, the tongue and groove method provides enhanced directional control, improved safety margins, and a predictable, professional quality fall even under challenging conditions. In Malaysia, a newly commissioned Wood-Mizer LT15 Start is being pushed to its operational limits as it works through some of the region's most extreme tropical hardwood. The LT15 Start, equipped with a 7 to 10 horsepower electric or petrol engine and a 28 to 32 millimeters blade, offers a cutting height range from 1 to 70 centimeters and supports logs up to 70 centimeters in diameter on its 6.4 meter bed, extendable for longer timber. These capabilities give the mill the rigidity and tracking precision needed for exceptionally dense species. While the exact wood isn't confirmed, its resistance and heavy fiber structure strongly indicate Shangal, one of Southeast Asia's hardest and most durable timbers. Even under these demanding conditions, the LT15 Start maintains smooth, accurate cuts. Its robust frame, stable bed, and well-supported blade guide system prevent vibration and deflection, while proper blade tensioning and tooth selection help the saw stay cool and efficient. The outcome is clean, uniform boards produced directly at the work site, demonstrating that even a compact LT15 Start is fully capable of processing industrial-grade tropical hardwood with consistency and reliability. The Morbark 2400 Woodhog is a compact but highly capable horizontal grinder designed to tackle a wide spectrum of wood processing demands. Operators can configure it with either a chip rotor for cleaner cuts or a hammer rotor fitted with 22 heavy-duty hammers for aggressive grinding and rapid material breakdown. The rotor assembly is engineered for quick changeovers, allowing crews to switch configurations with minimal downtime. Powered by a Volvo TAD 583 VE engine producing 238 horsepower, 175 kilowatts, the 2400 delivers strong throughput while maintaining fuel efficiency and stable torque under heavy load. It is capable of processing everything from branches and small logs to stumps, wood waste, sawdust, and mixed debris. The machine outputs uniform, semi-finished material in multiple fractions, making it a versatile solution for recycling facilities, land clearing operations, and biomass fuel preparation. In the realm of modern engineered wood manufacturing, the Sufoma MDF production line represents a pinnacle of integrated industrial engineering, where mechanical design, thermal control, automation, and material science converge into a single continuous operation. What distinguishes this system is not just the scale of its output, but the precision and orchestration behind each subsystem. Designed for a nominal throughput of 1,000 cubic meters of finished MDF per day, this particular plant has exceeded its design expectations, consistently reaching a stable production rate of 1,250 cubic meters per day. Achieving such performance requires more than powerful machinery. It depends on process harmony, equipment reliability, and real-time operational control across every stage of the line. Raw material preparation and log handling. The production journey begins long before the first fibers are formed. Raw logs, sourced from a mix of hardwood and softwood species, enter the facility through the log feeding conveyor, a heavy-duty chain conveyor built to handle variable log sizes, bark conditions, and moisture levels. The system's rugged construction ensures uninterrupted supply even in high-humidity tropical environments or variable supply chain conditions. This conveyor does more than simply transport wood. It regulates the entry rate into the system, helping stabilize downstream processes. Logs transition into the drum chipper, where large rotating cutting discs fitted with sharp tool steel knives break the raw material into clean, uniform chips. The geometry of the chipper, its disc diameter, inertia, and knife angle, is engineered to minimize fiber damage and reduce fines. Uniform chip dimensions are essential for refining, as inconsistent chips produce poor quality fibers that compromise mat formation and panel strength. After chipping, material is conveyed via a series of chips conveyors and chips chain conveyors toward the chip silo. This intermediate storage structure acts as a vital buffer, absorbing fluctuations in log supply and enabling constant feed to the refiner, even during upstream interruptions. Inside the silo, controlled airflow and automated discharge systems prevent bridging and ensure a smooth, consistent chip flow. Fiber production and thermal integration. Once chips leave the silo, they pass through the chip's discharge screw and onto the chip's belt conveyor, which meters them into the heart of the transformation process, the refiner. Here, mechanical and thermal energy work simultaneously to break chips down into fine, uniform, lignocellulosic fibers. The refiner operates under high-intensity conditions. Powerful motors rotate refining plates at high speeds, while steam injection softens the chips and reduces mechanical resistance. The design of the plate patterns, grooves, dams, and surface textures is calibrated to pull chips inward, defibrate them efficiently, and discharge clean fibers without generating excessive fines. The freshly refined fibers emerge hot and saturated with moisture, making immediate drying essential. Before the mat reaches a continuous press, it enters the pre-press. This machine gently compresses the loose fibers into a stable blanket, removing entrapped air pockets and improving mat uniformity. A high-precision edge trimming saw squares the edges, preparing the mat for seamless entry into the press line. Any material that deviates from quality standards, whether due to incorrect moisture, density, or contamination, is diverted via the rejection nose conveyor and recycle screw, returning valuable fibers to the system while ensuring only spec-compliant mats proceed. The core of the line, the 8-foot continuous press. Sufoma's self-developed 8-foot continuous press serves as the technological centerpiece of the entire production line. Its complexity lies not merely in the application of heat and pressure, but in the synchronization of its thermal, hydraulic, and mechanical systems. The press's driving system maintains steady movement of the mat through the press zones, while the hydraulic system controls daylight opening and closing forces. Meanwhile, a thermal oil secondary circulation system ensures stable heat distribution along the press length, creating a uniform curing environment. Inside the press, a series of controlled pressure stages and temperature zones gradually compress and bond the resin-impregnated fibers into a continuous panel. Temperature uniformity prevents internal blisters and delamination, while precise pressure profiling ensures consistent density from surface to core. This level of control is essential for meeting international MDF standards, where density variation, internal bond strength, bending strength, and surface quality are tightly regulated. Panel handling, resizing, and quality control. Upon exiting the press, the continuous board travels toward the diagonal saw. This automated cutting system slices the endless panel into individual boards, preparing them for downstream processing. Quality inspection at this stage is relentless. A thickness and blister meter continuously scans each panel for dimensional accuracy and internal defects. Boards that pass inspection continue forward. Those that fail are automatically removed from the production stream. Next, the boards move along a belt conveyor with an integrated scale, which feeds them into the cooling and stacking zone. Proper cooling is essential, as MDF panels retain significant internal heat after pressing. The Star Cooler, a large, rotating, multi-chambered system, gradually reduces the temperature of each board, preventing warping, internal stress buildup, and resin overcuring. Once cooled, the automated stacker, satellite trolley, and rotary trolley table work in unison to create stable, organized stacks. Equipment such as the feeding hydraulic lifter, board pusher, and alignment rollers ensure precise positioning and optimal load distribution. sanding, trimming, and final sizing. Surface calibration is performed using a multi-stage sanding system. The process begins with the two-head sander, which removes surface irregularities and prepares the board for finishing operations. The 4-hoe feeder ensures accurate alignment before the longitudinal book saw performs clean, dimensionally controlled cuts. Further trimming is completed by the longitudinal discharger, transversal servo feeder, and transversal book saw, producing boards in market-ready sizes. The transversal discharger then transfers finished board stacks to the shipping or storage area, completing the cycle. A fully integrated manufacturing ecosystem. What sets the Sufoma line apart is its seamless integration of complex subsystems. Precision mechanical engineering ensures long service life and consistent performance. Advanced automation coordinates real-time adjustments across the line. Thermal and hydraulic control systems provide stability during continuous 24/7 operation. Data-driven process management maintains quality and throughput. Material recapture systems reduce waste and improve resource efficiency. The plant's ability to exceed its design capacity from 1,000 m³ per day to 250 cubic meters per day demonstrates the robustness of Sufoma's engineering philosophy. Achieving a 25% performance margin without compromising product quality is a testament to the synergy of machine design, thermal integration, process automation, and operational discipline. Conclusion: a model for modern MDF manufacturing. This production line exemplifies the level of precision, reliability, and integration required in today's engineered wood industry. With continuous operation, high throughput, and consistent product quality, it highlights how modern MDF plants must function as cohesive ecosystems, where every conveyor, refiner, press, sensor, and feedback loop plays a vital role. From the moment raw logs enter the line to the final stacking of finished boards, Sufoma's MDF production system demonstrates the future of high-capacity wood panel manufacturing, fully automated, thermally optimized, and engineered to deliver quality at industrial scale. In the construction of the new I+R Holzbau production hall in Rotary, a groundbreaking material stepped into the spotlight: Biomass, an advanced form of beech-based laminated veneer lumber. This engineered timber product is produced through high-precision layering and pressing technologies, creating a material far stronger and stiffer than most traditional softwood alternatives. For decades, structural timber construction has relied almost exclusively on softwoods like spruce or fir. But with the development of modern manufacturing methods, beech, once considered too challenging for large structural components, can now be transformed into high-performance load-bearing elements. This shift opens the door to entirely new architectural, structural, and design possibilities. One of the most impressive advantages of Biomass lies in its exceptional mechanical properties. Its high strength and stiffness mean that beams and supports can be produced with far slimmer dimensions than typical softwood glulam, without compromising load capacity or safety. This increases material efficiency, reduces overall timber consumption, and contributes to a cleaner, more elegant structural appearance. For projects where the structure remains exposed, Biomass's fine layered texture and crisp edges offer a refined aesthetic that elevates the visual identity of the entire building. The construction of the production hall also integrates Biomass into the roof panel system, demonstrating the versatility of the material. During assembly, individual timber elements are positioned with the help of precision templates that ensure consistent alignment and accurate fit. This approach streamlines production, enabling workers to fabricate and install a large number of roof panels in a very short time frame. The high-dimensional stability of Biomass supports this process, ensuring uniform quality from panel to panel. Because both the beams and the roof elements were fully prefabricated off-site, the on-site assembly progressed with remarkable speed and predictability. In fact, the entire structural framework of the new production hall, spanning a significant footprint, was erected in just 2 days. This efficiency underscores one of the major advantages of engineered timber systems: rapid installation with minimal disruption, reduced labor requirements, and excellent construction reliability. In its completed form, the I+R Holzbau production hall stands as a showcase for what modern timber engineering can achieve. It demonstrates Biomass's ability to deliver a structure that is technically advanced, visually refined, economically efficient, and environmentally responsible. More than just a new material in a single building, Baubusch's successful use here marks an important milestone in the evolution of commercial timber construction, illustrating how innovative engineered wood products can redefine standards for strength, sustainability, and architectural expression in the years ahead. The manufacturing of luxury classic furniture is defined by an uncompromising dedication to craftsmanship, an approach where every detail is shaped by human skill rather than automated processes. In this presentation from Vimercati, we witness the essence of true Italian furniture artistry unfolding step by step, revealing why these furnishings stand apart as timeless heirlooms rather than mass-produced objects. The journey begins with a careful selection of premium hardwoods: walnut, mahogany, cherry, each chosen for its grain character, stability, and long-term durability. These timbers are cut and dimensioned manually, ensuring flawless alignment for the joinery to come. Skilled artisans then shape the structural components using time-honored techniques such as mortise and tenon joints, hand-carved profiles, and solid wood framing that ensure strength lasting for generations. As the foundation takes form, the process transitions into the decorative phase. Here, master carvers sculpt intricate floral motifs, scrolls, and classical reliefs, using chisels guided by decades of experience. Every carving is unique, carrying the subtle signature of the hands that crafted it. Veneer specialists follow with meticulous book matching and radial patterns, while marquetry artisans embed delicate inlays of contrasting woods, brass, or shimmering mother of pearl. The surfaces are then refined through careful sanding and layered finishing. Hand-applied lacquers, shellacs, and natural oils bring depth and warmth to the wood, while 22-karat gold leaf may be added, burnished to a soft, luxurious glow that defines traditional Italian elegance. Finally, upholstery masters complete the piece with premium fabrics, horsehair padding, and hand-stitched details that ensure comfort as well as beauty. Every stage of Vimercati's process is carried out entirely in Italy, preserving a lineage of craftsmanship that transforms each piece into a unique, irreplaceable work of art, created not merely to furnish a home, but to embody generations of refinement. In Chile's thriving forestry sector, one industrial complex rises above the rest, a factory recognized as the nation's largest and most advanced producer of wood furniture. It is a place where scale, craftsmanship, and technology converge seamlessly to produce high-quality furnishings for the international market. Here, raw logs enter at one end of the facility and export-ready luxury furniture exits at the other, all flowing through a meticulously integrated production chain that blends traditional woodworking knowledge with automated precision. The journey begins at the administration department, the strategic nerve center of the entire operation. This team manages procurement, coordinates production schedules, oversees inventory, and organizes the complex export logistics required for worldwide distribution. Their work ensures that every department downstream receives the right materials at the right time, enabling a continuous, balanced workflow. From there, the process moves outdoors to the Cancha de Acopio, the massive log yard, where truckloads of timber arrive daily. Here, the raw material is sorted, tagged, and classified by species and quality. The factory primarily handles radiata pine, native Chilean hardwoods, and sustainably certified timber. Each log is documented to ensure full traceability, a critical factor for export markets that demand environmental compliance and responsible sourcing. Once sorted, the logs enter the first major mechanical stage at the descortizadora. These industrial debarking machines peel away bark with speed and precision, removing contaminants that could damage sawmill blades or compromise surface quality. This preparation step might seem simple, but for a large-scale factory, efficiency here is vital. Clean logs allow cleaner cuts and safer, smoother operation inside the mill. The debarked logs proceed into the aserradero, the heart of the primary processing division. This high-capacity sawmill is equipped with powerful cutting systems and intelligent optimization software. Before each log is cut, digital scanners analyze its shape, diameter, and internal characteristics, calculating the best cutting pattern to maximize usable lumber. The result is a variety of slabs, planks, and dimensional boards produced with minimal waste. Even the offcuts have a purpose in this closed-loop ecosystem. All residual material, sawdust, small chips, slabs, and bark is immediately classified as subproducto. Instead of being discarded, these byproducts are later transformed into briquettes or directed into thermal energy systems that help power the facility's dryers and boilers. Nothing is wasted, everything is repurposed. Tools within the sawmill are kept in peak condition through a strict mantención de herramientas CATA 4 HR's protocol. Every 4 hours, blades, knives, and cutters are inspected, sharpened, or replaced by skilled technicians. This routine ensures the cutting quality remains consistent, reduces fiber tear-out, and guarantees uniform dimensions across thousands of boards produced each day. Freshly sawn lumber is then transported to the almacenamiento aserradero, a sheltered yet ventilated holding area where boards are organized by thickness, width, and moisture content. This staging zone prepares the material for one of the most crucial phases of production: controlled drying. In the secado section, massive kiln chambers carefully regulate temperature, humidity, and airflow to draw moisture out of the wood. Drying cycles can last several days and must be precisely controlled to avoid warping, cracking, or internal stress. Technicians perform medition percent humidad using digital moisture meters, ensuring every batch reaches the target moisture range, typically 8% to 12%, depending on the final product. Once the wood has been properly conditioned, it moves into cepillado and trazado. Industrial planers refine the board surfaces, creating smooth, standardized thicknesses, while crosscut saws trim the boards into precise working lengths. This is where rough lumber starts to transform into components suitable for fine furniture manufacturing. Next comes preparation, a critical stage where visual harmony and structural integrity begin to take shape. Workers sort boards by grain pattern, color tone, and natural characteristics, ensuring that each furniture piece will have a uniform and aesthetically pleasing appearance. Higher grade components are selected for visible surfaces, while structurally sound but visually varied boards are reserved for internal framework. Boards requiring decorative profiles then travel to the molderera line, where CNC-controlled molding machines sculpt edges, shapes, and precision contours. For wider surfaces or engineered structures, the encoladora plays a key role. This automated gluing system bonds smaller boards into larger, perfectly flat panels. High-pressure clamps ensure even adhesion, producing panels stable enough for tabletops, cabinet sides, shelves, and structural cores. Quality control, control calidad, is an ever-present force throughout the factory. Inspectors evaluate dimensional accuracy, joint integrity, moisture content, and surface perfection. Their oversight ensures flawless components advance to the next stage. At the technological center of the facility lies the Sección Maquinas, an area filled with advanced woodworking machinery. CNC routers, shapers, and cutters carry out operations that once required hours of manual craftsmanship. The standout here is the Pantografo Morbidelli, an Italian CNC machining center capable of producing intricate carvings, precision joinery, and elaborate geometries. This machine enables the factory to develop custom lines and meet unique design requirements requested by international clients. Meanwhile, all leftover dust and scrap material are processed into briquetas. These high-density fuel blocks feed the facility's Unidad Térmica, supplying heat for boilers, drying chambers, and other thermal systems. This sustainable energy loop significantly reduces environmental impact and lowers operational costs. Once every component has been shaped, the process transitions into armado assembly. Skilled technicians use dowels, mortise and tenon joints, structural adhesives, and metal fittings to bring the furniture to life. Frames are squared, surfaces aligned, and joints reinforced to meet strict export durability standards. Here, craftsmanship takes center stage once more, blending human precision with the consistency of high-tech machining. The assembled pieces then move into the finishing department. The first stage, pintura, involves applying stains or colorants to enhance the wood grain or achieve specific tones requested by clients. After tinting, the furniture enters salado, where surface sealers lock in the color and prepare the wood for the lacquer layers. Finally comes lacado, the step that gives the furniture its luxurious appearance and robust protection. Using controlled spray booths, operators apply multiple layers of lacquer, building up either a high-gloss reflective sheen or a matte, modern finish. The curing process ensures resistance to scratches, moisture, and UV exposure, making each piece ready for years of use in homes, hotels, and commercial spaces worldwide. By the time the furniture exits the finishing line, it has traveled through an entire ecosystem of engineering, craftsmanship, sustainability, and precision. What began as raw logs in the yard is now refined, durable, beautifully finished furniture ready to be packed, loaded, and shipped to global destinations. With its fully integrated operations, spanning raw material intake, advanced machining, environmentally conscious energy systems, and high-end finishing, this Chilean giant stands as a world-class benchmark in wood furniture manufacturing. It demonstrates how scale and sustainability can coexist with artisanal detail, producing exceptional furniture that is ready to be delivered anywhere in the world at any time. Working with a massive, storm-damaged giant redwood is more than just timber harvesting. It's a rare blend of arboriculture, risk management, and precision sawmilling. This project follows the full journey of one such tree, tracing its transformation from a compromised giant in the forest to beautifully milled, wide-format lumber produced on a Wood-Mizer LT15 wide sawmill. Every step reflects careful planning, technical expertise, and respect for a tree that had stood for generations. Because this particular giant redwood had suffered structural damage during a major storm, the operation began long before any saw touched the wood. A specialist arborist was brought in to climb the towering trunk, a task requiring skill, physical endurance, and an intimate understanding of tree mechanics. As he ascended, he assessed fractures, internal splits, and shear lines, determining whether the tree still carried dangerous tensions. Only by identifying stable anchor points and safe cutting positions could the team prevent catastrophic failure during felling. The arborist then began pre-reducing the upper sections, cutting away height in stages so that the remaining stem would fit within the limited felling gap below. It was a deliberate, methodical process designed to reduce weight, lower risk, and maintain complete control over the compromised structure. With the upper crown removed and the final assessments complete, the main stem was ready for felling. Even at this reduced height, the trunk carried immense weight and stored energy. The team executed a clean, controlled felling cut, allowing the huge redwood to drop precisely where intended. Safety considerations guided every movement. This was not just cutting down a tree, but safely dismantling a natural giant under challenging conditions. Once on the ground, the work transitioned from arboriculture to heavy timber extraction. The trunk was cross-cut into more manageable sections, each still incredibly large and dense. Giant redwood logs are notorious for their weight, and even with modern equipment, the removal process was slow and demanding. Winches strained, levers creaked, and the crew worked steadily to inch each log toward the roadside. In fact, it took an entire day just to extract 3 sections. Some parts of the trunk were simply too heavy for the available machinery and had to be left behind until more powerful handling equipment could be brought in. Eventually, the smallest of the giant logs reached the sawmill, though calling it small hardly does justice to its size. This log became the focus of the milling operation on the Wood-Mizer LT15 wide, a sawmill designed to tackle oversized and irregular timber. Before any milling could begin, the log had to be carefully leveled on the bed. The team worked to ensure that the center line of the trunk sat perfectly stable. Proper leveling is crucial. Even slight variations in taper can create inconsistent board thickness or blade drift. By taking the time to align the log correctly, the sawyers set the stage for clean, predictable cuts. The operation wastes nothing. Slatwood, the curved outer portions of the trunk that are unsuitable for structural boards, was set aside to be processed into firewood billets. These billets will later be dried in the kiln visible on site, ensuring efficient combustion and making use of every possible part of the tree. With the setup complete, the Wood-Mizer LT15 wide began the breakdown. The first passes produced a pair of impressively wide boards, showcasing the sawmill's generous throat capacity. As the cut sequence continued, the sawyers formed 2 smaller cants, destined to become 150mm boards, material well suited for outdoor structural use. The breadth of the redwood allowed the mill to generate exceptionally wide, visually striking boards that capture the characteristic grain and warm tones of the species. Next came the jacket boards, slabs that still contain the lighter-colored sapwood along their outer edges. For redwood, the sapwood is not durable outdoors and must be removed if the timber is to be used in exposed environments. Later at the edger, this sapwood will be trimmed away, leaving only the dense, high-quality heartwood that makes redwood so desirable. To protect the freshly milled timber, the team applied a chestnut-based end seal to the exposed end grain. This step is essential for preventing end checking, those familiar radial cracks that occur when the ends of boards dry too quickly compared to their interior. Sealing slows the moisture release, helping the boards dry evenly and preserving their structural integrity. By the end of the milling session, the sawmill had produced a clean batch of 150mm boards ready for outdoor use. One of the remarkable attributes of giant redwood is the natural durability of its heartwood. Even without chemical treatment, redwood heartwood resists decay exceptionally well, making it ideal for decking, pergolas, outdoor structures, and specialty woodworking projects where both longevity and beauty matter. From the demanding climb to the precision felling, from the slow extraction of massive logs to the fine-tuned cutting of wide boards on the LT40 wide, this project reveals the full value contained within a storm-damaged giant redwood. Through careful recovery, thoughtful milling, and a commitment to honoring the material, the tree's legacy now continues in the form of strong, beautiful, long-lasting timber, ready to be used in projects that will endure for decades to come. The RG's VZ750D is a heavy-duty, twin-shaft industrial shredder designed specifically for the toughest wood processing challenges, handling large tree trunks, solid wood waste, and dense biomass with ease. At the heart of the machine is a powerful 235-kilowatt Volvo Penta diesel engine, providing the immense torque needed to drive the shredder's robust shaft system. This powertrain ensures consistent performance even when dealing with oversized, irregular, or heavily knotted timber. Each of the shredder's massive shafts measures 750 millimeters in diameter, forming a rugged dual-shaft configuration that pulls material inward, where it is sheared, crushed, and broken down into manageable fragments. Loading these bulky materials is made easier by two hydraulically tiltable hoppers, which let operators guide large logs into the machine with precision and maintain steady, controlled feeding. As material is processed, a long discharge conveyor, engineered with an impressive discharge height, efficiently removes the shredded output, helping prevent backups and ensuring smooth, uninterrupted workflow. At the core of the shredding system is RG's patented T-blade profile, a unique cutting design that delivers clean, energy-efficient shredding while reducing blade wear and maintenance demands. In operation, the RG's VZ750D transforms massive, unwieldy tree trunks into reusable wood chips or biomass-ready material with remarkable reliability. For forestry operations, biomass production, and wood recycling facilities, it stands out as a powerful, versatile solution for heavy-duty trunk wood reduction. The Peterson 571OD horizontal grinder is a powerful, track-mounted machine built for serious, high-volume material reduction. Designed for demanding forestry and recycling operations, it's driven by a Caterpillar C27 diesel engine, delivering a remarkable power-to-weight ratio. This engine allows the 571OD to tackle full-length tree trunks, massive stumps, and dense green waste without hesitation. One of its standout advantages is the large 152 by 102 centimeter feed opening. Paired with a high-lift feed roll, the grinder can accept entire logs and oversized woody material without any pre-processing, keeping production fast and efficient. Inside the grinding chamber, a heavy-duty rotor fitted with 22 cutting bits operates at around 840 revolutions per minute, generating tremendous impact force. This enables the machine to break down tough, fibrous, or oversized material into usable mulch, biomass fuel, or chip-sized output. The 571OD uses a 3-stage grinding system, helping produce a uniform final product tailored to the job's requirements. And because it's a track-mounted unit, the grinder can position itself directly at the worksite. With an optional tow dolly, it can also be relocated quickly between jobs, making it ideal for land clearing, storm debris cleanup, large-scale composting, and biomass production. Massive logs arrive at the mill, towering conifers harvested for their straight grain, uniform diameter, and consistent fiber quality. These are the giants that become the foundation of the global plywood industry. In facilities like this, raw timber meets high automation engineering, where nature's strength is transformed into engineered performance materials used in construction, furniture, and manufacturing around the world. The journey begins the moment the logs are unloaded onto the automated handling line. Built for continuous high-volume production, every step is designed to maintain rhythm and precision. The first stage is log sizing. Here, hydraulic saws cut each log into standardized lengths, typically around 1,000 millimeters. These cuts ensure perfect compatibility with the rotary lathe further down the line and maintain dimensional accuracy throughout the entire process. From there, the logs move into the debarking unit. It's a violent but controlled step. Rotating steel tooth drums tear off the bark, dust, and surface contaminants that accumulate during transport. Removing this material doesn't just clean the log. It protects the peeling blade from premature wear and ensures a smoother, more consistent veneer surface later on. Now clean and uniform, the logs enter the heart of the operation, the centering and clamping system of the rotary veneer lathe. With hydraulic precision, the machine measures the exact center line of each log, adjusting automatically to maintain balance. High-strength spindles grip both ends, locking the log firmly in place. As rotation begins, the machine stabilizes the entire structure, creating the perfect conditions for peeling. At this point, the wide industrial peeling knife begins its work. It advances toward the spinning log with micrometer-level accuracy. As the blade meets the wood, a continuous sheet of veneer begins to unfurl, peeling off in a long, perfectly controlled ribbon. What was once a solid cylinder of wood transforms into a thin, uniform sheet that may stretch hundreds of meters in length. Veneer thickness, typically ranging from 0.5 millimeter to around 3 millimeters, is constantly adjusted by onboard sensors, depending on whether the sheets will become plywood, laminated veneer lumber, or high-grade engineered panels. The freshly peeled veneer travels along conveyors to the next stage. Automated optical scanners evaluate each sheet, checking for surface defects, moisture inconsistency, or irregular thickness. Anything unsuitable for top-grade panels is marked and automatically diverted for appropriate sorting. From here, veneer sheets enter the drying tunnel, a long, temperature-controlled chamber that brings moisture levels down to precisely calculated targets. Proper drying prevents future warping and ensures that glue bonding in the plywood press will be strong and uniform. Once dried, sheets are trimmed to size, graded according to quality, and neatly stacked into bundles ready for panel assembly. Meanwhile, the cylindrical core that remains after peeling the last solid piece of the original log is transported away for chipping or used as biomass fuel. Nothing is wasted. Every part of the tree is routed toward a productive purpose. When paired with high-pressure veneer hot presses, automated glue spreaders, and computerized feeding systems, the rotary cut veneer line becomes the backbone of modern plywood production. It combines precision engineering with efficient resource use, turning each coniferous log into a high-performance, globally relied upon building material. From log to finished panel, every step reflects decades of innovation, maximizing yield, reducing waste, and delivering the thin, flawless sheets that make plywood one of the world's most essential engineered wood products.